And in this session, we're going to take a look at chapter 10, which is correlation. And the main thing we're going to be doing is using the calculator to find the correlation. And we'll talk about more about correlation in just a second. The very first thing that I'm going to do is I'm actually going to bring up the textbook. And just so that we're all on the same page, if you're in the My Math Lab course, sorry, and under this multimedia library section, I'm going to click multimedia library. I'm going to click on multimedia textbook, and I'm going to click find now. And if I scroll down, I'm going to choose chapter 10 correlation. And the reason why I show you this, if you started the chapter 10 homework, you're asked for some critical R values, and the critical R values, they're sort of hidden in the book, and I just want you to know where you can find these things. So for chapter 10, we're going to talk about correlation. And in using the book, I'm just going to pull out some definitions and terms and concepts to kind of get us started before we actually use a calculator. And what a correlation exists between two variables where one variable is somehow associated with the other variable. So that doesn't necessarily mean that one causes the other. It just shows a correlation shows that they're somehow associated. A more special type of correlation is called a linear correlation. And a linear correlation exists between two variables when there's a correlation. The correlation is plotted by pairs of data and a straight line appears. If we get that straight line, linear and line are one and the same, so that linear correlation would be the strength or the straightness of that line when those two pairs of data are plotted. Okay, so in particular, we're going to talk about a linear correlation. And when we talk about a linear correlation, okay, I'm just going to go to our next page. A linear correlation exists when two pairs of data are plotted, and you can use what's called the R value, which is the linear correlation value, to measure the strength of that linear relationship. So just taking a look at these four examples, as you read these correlations, we read them just as sentences, we read them from left to right. And if we look at figure A, notice as we read this graph from left to right, it ascends, or it sort of goes up in a straight line. Since our line, right, is straight and it's rising as we read it from left to right, it would actually have a positive correlation. So here that positive correlation is estimated at 0.859. If we take a look at figure B, notice as we read this graph from left to right, it descends in a linear pattern. This particular graph would have a negative correlation, which is approximately negative 0.971. If we look at the third, or C, We look at this diagram, notice that there is no correlation. As we read it from left to right, a line does not appear. The points appear scattered. So there's no relationship. So notice the R value here is 0.074, okay, which is close to 0. If we look at our last figure D, notice that as we read this graph from left to right, it's not a linear pattern. It's more like a parabola type deal, which is not linear. What we're searching for are linear correlations. So looking at this last figure, there's no relationship and it's estimated to be 0.33. Now, as we can tell from our drawings or from our figures, okay, now I'm actually going to flip to page 473. We're going to talk about some properties of R. Okay, so this is from page 473 in your book. And one of the main properties of R is that R is always between -1 and +1. Right? So your R value shows strong linear relationship when it's close to -1 or close to +1. Some other properties about R values, if you can change X and Y, right? You would still get the same R value. R measures the strength of the linear relationship. It's not designed to measure the strength of the relationship that is not linear. So this R only applies to linear relationships. It also states that R is sensitive to outliers. All right, so we're going to use this knowledge and we're actually going to take a look at the homework and we're going to answer problem number 19. Okay, so if you can answer problem number 19, you can answer the rest of the problems through 30. Okay, so we're going to take some time and kind of thoroughly explain how this problem is done. Now, I'm actually going to do it two ways. I have a TI-83 that's actually on my screen, but I also have a handheld TI-84 Plus. So I'll kind of go through the steps first using the TI-83, and then I'll switch to the document camera and we'll use the TI-84. Okay, but the key step should be the same for the two calculators. All right, so the first thing I'm going to do is I'm going to just reset my calculator. So now I'm using a virtual calculator. So the way I reset my calculator will be a little bit different than the way you reset yours. Okay, and the reason why I'm resetting it is because we're going to do some things and I have to go and change certain functions in the calculator. And if you're in the default format, okay, you'd have to change them as well. Okay, so now we'll take a look at the problem. And it says, listed below are the overhead widths in centimeters of seals measured from photographs and the weights of these seals. We're given the critical values of R. We're asked to find the critical values of R, and our alpha level is 0.01. And we want to determine, is there sufficient evidence to conclude that there is a linear relationship between overheated widths of seals from photographs and the weights of the seals. All right, so the first thing we want to do is we want to construct a scatter plot. So in order to construct a scatter plot, I'm going to take my overhead width and I'm going to treat that as X or L1 in my calculator. I'm going to take the weight, I'm going to treat that as Y or L2 in my calculator. So in order to plot these points, the first thing we want to do is we want to put the points in our calculator. So I'm going to hit Stat. I want Edit, so I'm going to hit Enter. Now you want to make sure that when you're doing this, you have L1 and L2 that you're using. If you have anything other than L1 and L2, we can reset our list. So this is how you will reset your list. I want to go back to the home screen, which is second and quit. I want to hit stats. I want to go down to setup editor, hit enter, and if I hit enter again, it says done. What this should do is if I now go back into my list, I'm going to go to stat, I'm going to hit enter. Right, you should now see L1, L2, L3. Let's say you have some data in your list. And so I'm just putting some random numbers in. In order to clear my list, I could go in and hit delete for every entry. Or if I had a lot of numbers in my list, I could go to the very top. I could hit clear and enter. And that would erase all of the numbers in the list. All right, so now what I'm going to do is enter in the overhead weights as L1 and, the overhead width as L1 and the weights as L2. Right, so now I'm just checking. Okay, so once you have the data points in list 1 and list 2, the second thing I'm going to do is I'm going to go into y equals, and if you have any equations, you want to clear those out. All right, so I don't have any equations in my y equals. The next thing I'm going to do is I'm going to go into stat plot. So I want to hit second and y equal, which is stat plot. While we're in the stat plot area, we want to turn on the stat plot, right, which will allow us to make a scatter plot. So stat plot 1 is highlighted. I'm going to press enter. Next, I want to turn it on. So where it says on, I'm going to press enter. So now notice that on is blinking. For my type, by default, the very first box is highlighted, and this is what we want. Okay, I'm going to leave in X as list 1, Y as list 2, and what mark means is these are the symbols it's going to grab. So I'm going to leave it at this default symbol. Next, in order to produce the graph, I'm going to go into Zoom. I'm going to scroll down to Stats, which is Zoom 9, and I'm going to hit enter. All right, so this is our stat plot. So as I choose from my points, sorry about that, I think it should be D. right, A and D were close. All right, now it asks for a linear coefficient. All right, so for our linear coefficient, I want to go into catalog, which is above 0, and it's yellow, so I want to hit second and 0, and it takes me to this catalog. The next thing I want to do is I want to scroll down until I get to the D's, and you should see something that says diagnostic off and diagnostic on. I want to turn my diagnostic on, and I want to hit enter. And now I'm going to hit enter again. Now what this diagnostic on does is it gives you the R value. So if this diagnostic is turned on, you don't necessarily have to turn it on again unless your R value disappears, which we'll talk about in a second. All right, so now that the diagnostic is turned on, here is how we will compute this linear correlation coefficient R. I'm going to go back into stat. I want to scroll over to calculate, and I want to scroll down to this linear regression AX plus B. Okay, so if you remember from your college algebra class, this is linear regression, just taking these points and producing a line based on these data points. All right, so linear regression is chosen. I'm going to hit enter once. I'm going to hit enter again. And notice we have our R value, which is 0.849. So now whenever you're asked to find the R value again, you never have to turn that diagnostic on. The only way you'll turn it on if for some reason your R value disappears. All right, so now we're asked for what are called the critical values of R. Now here's where the critical values of R can be found. So I'm going to pull up the textbook, and I want to turn to, this is table A6, which is on page 692. And here are the critical values of R. Okay, so here's how you read or find the critical values. First, you'll be given, or you have to input in, that would be the number of data points. And if your alpha level is 0.05, right, here are your critical values, and they would be plus or minus. If your alpha level is 0.01, here are your critical values. So in our problem, we need to determine N, and we also need to determine alpha. So if I go back to our problem, N would be the number of data points. So we have 6 data points, 1, 2, 3, 4, 5, 6. So N would be 6. Alpha is 0.01. So if I go back to our chart, we find N is 6, alpha is 0.01. So we have critical R values as plus or minus 0.917. So our critical R values are plus or minus 0.917. All right, so once again, the critical values for R are found in your textbook on page 692. And in order to find the R value, you will have to know N and your alpha level. All right, so we have the R values is plus or minus 0.971. Okay, now we need to make a determination. So we're going to look at the absolute value of the linear correlation coefficient, which is 0.849. The critical values are plus or minus 0.971. So notice that this value does not fall within our critical values. It's actually less. So because the absolute value of the linear coefficient is less than the positive critical value, there is not sufficient enough evidence to claim that there is a linear correlation. All right. So if your R value falls within your critical values, right, if it's greater, there would be evidence to support. But since our linear correlation falls outside of our critical R values, there is not enough evidence to support. All right, so just by knowing how to do this problem, right, find the R value, how to find the critical R values, okay, you should have enough information to do the rest of the problems for chapter 10. All right, so here I'm going to stop the recording. Well, no, actually, I'll go through the TI-84. Okay, just in case the keystrokes were a little bit different. Okay, so give me 1 second. I'm going to turn this on. So here's an example of a calculator that hasn't been reset. So first thing I'm going to do is clear out all of the data. So in list 1, I'm going to go to the very top. I'm going to hit clear and enter. It may be hard to see that. Okay, the very top of L2, clear and enter. And the next thing I'm going to do is enter the points. So we had 7, 7.5. Excuse me, this should be L1. 7, 7.5, 9.8, 9.3, 8.8, 8.2, And for L2, 106, 195, 248, 197, 201, 188. Okay, so L1, L2. The next thing I want to do is go to y equals, and I do have a function in there, so let me clear that out. Okay, so my y equals is cleared. I want to go into stat plot, so I'm going to hit second and y equals. I'm going to go into stat plot 1, turn it on. So notice here there is no graph highlighted for type, so I'm going to go to type. I'm going to go to the scatter plot, turn it on. Right, my X is L1, Y is L2. It's chosen a symbol by default, so I'm going to choose zoom stat, okay, which is zoom 9, and that's our scatter plot. Okay, so now this is what I mean about turning that diagnostics on. So let's just say I'm going to calculate R. So I want to hit stat. I want to go over to calculate. And if I go down to linear regression, hit enter once. Okay, so it says that X is L1, Y is L2. The frequency of L1 is L1. The frequency list is L2. Okay, we're going to leave all of that the same. I'm going to simply go down to calculate. And notice you do not have an R value. That's because the diagnostics are not turned on. So if I were to turn on my diagnostics, I'm going to go into catalog, which is second and 0. I want to scroll down to D, or if I look at my green characters, I see that D is above this X inverse symbol. So if I hit that, I'll kind of cheat and take me to the D's. If I find my diagnostic on, right, turn that on. So now if I go back into stat, calculate the linear regression, I go down to calculate. And I think I put my data points in not right or something. But notice that my R value appears. Okay, let me check my data points because I'm getting something a little bit different. Yes, I'm just going back in the stat. Okay, yeah, this should be 7.6. 9.8, 9.3, 8.8. I think that's where my data point was. And now I get the right R value. All right, so now I'm going to stop the recording.